Now we can also use completing the square to work with leading coefficients for different problems, right? You may have a positive coefficient leading the x squared term or a negative one. And in both cases, we have to see these as things that can be feasibly done. And we shouldn't be intimidated by them at all. So what we're going to do here is we're going to work a couple of them out. We're going to start off with f of x, then we're going to move on to g of x here. So to do this one now, it works a little different. As you've seen in the whole entire video, we've been dealing with problems where we don't have leading coefficients, and now we do. And so whenever you have a leading coefficient, it's just one extra step compared to everything else that you've already been doing. It's a couple things you have to know about what you're doing with it based on factoring. So let's take a look at how that works. So when we're doing the completed square for this one, we're just using one hand of the equation. We're not using both sides of the equation in this case. So we're going to be adding and subtracting the completed square to both sides of the problem. Our first step is to take the x terms and isolate them from the constant. So we have here 2x squared minus x, and here we just leave the plus 3 out of the parentheses. The next step is we need this to be a single, a 1 instead of a constant, right? So we're going to take this coefficient and factor it out of the inside of here. What happens is the 2 comes outside. When we factor 2 out of 2x squared, we're just left with x squared. And when we factor 2 out of negative 1x, we're just left with negative 1/2 x, right? And that's the constant being factored out. And the next step is we're going to take half the middle term and add it and subtract it to the inside of the parentheses. Okay, so here we're going to have 2x squared minus 1/2 x plus 1/2 divided by 2 would be 1/4, and this is also a negative 1/2. So we're going to have negative 1/4 squared minus negative 1/4 squared plus 3. And our next step is then to extract the negative 1 out of inside the parentheses to outside. And the reason for that is we have the perfectly completed square just right here on our left-hand side. We always take the one with the plus for completing the square because we know whenever you square a term, it turns positive. So here we have 2x squared minus 1/2 x plus negative 1/4 squared. Again, I'm not touching this because I need the x squared and the term squared, so I see the sign. And here when I factor out this term, when it comes out of the parenthesis, it's going to multiply by the leading term here. So I'm going to have a minus 2 parenthesis negative 1/4 squared plus 3. All right, now here we have the completed square, so we're going to take the 2, leave it outside, the x comes in, the negative 1/4 comes in, we close off the perfect square, and we can evaluate everything else over here. So we have negative 2, negative 1/4 squared becomes 1 over 16 plus 3. Next step, we can simplify this. The 2 and the 16 reduce. The 2 becomes a 1, 16 becomes an 8. So this is negative 1/8. So we have 2x minus 1/4 squared minus 1/8. And we want to complete the LCD here, right? Because this is 1/8. And so we multiply the top and bottom by 8. This becomes 24 over 8. And then we're subtracting these two from each other, right? So 24 positive, negative 1/8, positive 24 over 8. And that becomes just positive 23 over 8. And here we have our completed square with a leading coefficient. So here we have our f of x completed. Now let's work out our g of x, right? And in this case, instead of having a positive coefficient, we notice we have a negative one. So it's a bit trickier, but it's not so complicated. Everything pretty much runs the same. Let's take a look at the work. Now again, we're only working on one hand of the equation, and so we won't be setting this equal to 0 or anything like that. But the work, again, is exactly the same. What we want to do is we want to isolate our x terms. So we're going to put these first in parentheses, leave the 5 outside of the parentheses. And again, we're going to factor out the leading term here. The leading term's coefficient, actually. Not the leading term, just the coefficient, the negative 2. When we factor out that negative 2, what do we have left in here? Well, we have x squared as a positive. It was negative. And this here is going to be this number divided by this number. So 11 divided by negative 2 gives us negative 11 over 2 with an x. And here we still have that negative 5 out there. And now, again, we're looking to find half of the middle term. We're going to add it and subtract it to inside of this parenthesis set. So if you have a fraction, the easy way to do this is just multiply your denominator by 2, and that's actually half your middle term, right? So here we have negative 2, x squared minus 11 halves of x, plus half of the middle term here is going to be a negative 11 over 4 squared minus negative 11 over 4 squared. Close the parentheses, subtract the 5 outside. And again, all we need is the positive term here. We don't need the negative one, so we're just going to push this out while multiplying it by the coefficient that's leading the parenthesis set so that we have the same exact value, right? So here we have the negative 2, x squared minus 11 over 2x's, plus negative 11 over 4, perfectly squared. Here's our completed square. And outside of the parentheses is going to go this negative. So when I take that negative out, this negative times that negative, which we're going to multiply because we're pulling it out of the brackets, the parentheses, is going to be negative 2 times negative 1, which is positive 2. And then we take this and move it out with the trip as well. This is negative 11 over 4 being squared minus 5. Now don't worry too much about this second one because as we see it's being squared and that negative sign is always going to turn to a positive. So we don't have much to worry about. So here we have negative 2. Completed the square. Let's draw in the two pieces. We have x on this side, negative 11 over 4 on this side. It's perfectly squared. And then we're just going to rewrite everything while simplifying as much as we can. So we have the positive 2, negative 11 over 4 squared. Well, we know that this is going to become a positive, first of all. 11 squared is 121. And 4 squared is 16. And this is just being subtracted by 5. We're going to go ahead and put this over a 1 really quickly because we know we're going to have to do some LCD work. Let's simplify what we can. This 2 and this 16, they reduce. This becomes a 1. This becomes an 8. So we know the LCD is going to involve an 8 here. So let's multiply by 8 on top and bottom ahead of time. And that should look nicely. It's working out pretty all right. So here we have negative 2, x minus 11 over 4 squared. This here gives us 121 over 8. This here is going to give us negative 40 over 8. And we're just subtracting the numerators here because they have the common denominator and we're done. So here we have negative 2, x minus 11 over 4 squared, 121 minus 40. Let's just think of this as 120 instead of 121. That becomes 80. Add the 1, that's 81 over 8. Don't forget the signs on yours. This is bigger than this, so we keep this sign. And there we have it. We have the completed square with the leading coefficient. Thank you.